Right, hi everyone. We'll get started. Okay. Welcome. Hopefully everyone had a good snow day yesterday. No one had any traumatic effects with the snow. I think there was more snow when I went to bed before when I woke up. But that was a nice surprise. Um, I don't really think I have any announcements. I think you have a quiz next week, like an actual quiz. So just keep in mind about that. And then I think that's it. I don't think your first exam is not until like 2.5 weeks or so. So got a little bit of time, but it is on the horizon. So hopefully you're not scared by that. Other than that, are there any questions for me before we get started? Okay, what would you like to see today? Yeah, absolutely. Yep. So when we talk about conversions from moles to mass, what are we going to use? What do we learn today that's going to help us with this? The molecular weight or the molar mass, right? We can have molecular weight or molar mass. Howdy. Hello. All right, these are going to be interchangeable. It doesn't really matter what you call it. Both of them are the same thing. All right. What is our unit if we talk about the molar mass of something? Right, so your molar mass is going to be in grams per mole. All right, this is very similar to an AMU. Honestly, we don't talk about AMUs too much. It's probably just an introduction topic, but everything can be expressed in grams per mole, and that's usually what you use it in. You're going to see AMUs when you talk about like the percent abundance of stuff, but you can consider it grams per mole. It's going to be the same thing. So I like to use grams per mole. That's what most of the chemists use. I think AMU is just if you're like really specific into isotopes. So don't worry about that one too much. Right, so this is going to be grams per mole. What did we say a mole was? What is a mole? This is going to be a unit of measurement. Right? You can consider it kind of like a dozen, right? We said that a dozen, how much is in a dozen? Is in 12. A mole is, does anyone remember the number? 6.022 Perfect, right? 6.022 times 10 to the 23. I will mostly use 6.02 times 10 to the 23. Use what's given on your formula sheet in your exams, or in the question if it tells you that. But 6.02 is usually going to get you the right answer. So that's good enough for there. Mole Day was back in October of last year, right? 10/23. And people also celebrate on June 2nd. So it's a big deal in the chemistry world. But this is the mole. You'll see this all the time. It's a lot of using this right now for conversions, right? You're going to talk about masses right now. You're going to talk about atoms. You're going to talk about compounds. You're going to see 6.02 times 10 to 23 a lot. But you will see the mole in everything you do in chemistry. I used the molar mass of something today in lab. I had to calculate the number of moles of something that I needed. I needed to calculate the mass of something using the number of moles. This does not go away, so make sure you understand this. Please ask me if you don't understand it. But the mole is super important. So if you go to any of the chemistry things on campus, usually there is someone in a mole costume running around. And you can get little mole plushies. So that's really fun. So the mole is huge. Figuratively and literally, it's a massive number. So when we talk about conversions of grams to moles, where do we get that molar mass from? We get it from the periodic table, so. Right, when we're looking at carbon, it has 12.01 at the bottom. This is your molar mass. Right, that's what you're going to use for all of your molar masses. We have questions on finding the molar mass of a compound. Okay. So if I were to ask and I said, what would be the molar mass of CH2O? And how did you get that? Mhm.
12.01
Mhm.
plus 2 times 1.01
Perfect.
plus 16.
Awesome, right? So what is that? 28, 30.03 grams per. Okay. You can do that for anything on the periodic table. As long as you can combine it together, you can find the molar mass of that substance.
Molar mass and molecular mass are interchangeable.
And same thing, right? Molecular weight, molar mass, is just talking about the mass of that compound.
Is there anything between those two that will be mixed up or anything or something like that?
Same thing all the way around. Yep. Alrighty. So if I were to say, right, if there are 60.06 grams of CH2O, how many moles do you have? Can anyone do that quickly? Right, so now let's use our dimensional analysis. What are we starting with? 60.06. We need to get to the moles of CH26. How do we convert between grams and moles? Not yet. Not yet. Now we need the molar mass, right? We have grams, we need to get to moles. Where do we see grams and moles combined? That's in our molar mass. So if we start with grams, then we're going to have, right, for every 1 mole of CH2O, how many grams of CH2O do we have? 30.03. So when we do multiplication and division, right, we have our grams on top and our grams on bottom. So we're just left with moles. So that put us in the unit that we want. Yes, right? I'm asking for how many moles do you have? You're left with your unit of moles. So how many moles of CH2O do you have? You have 2. What questions do we have just from solving from grams to moles? Does that make sense how we use the molar mass in order to do that conversion? Okay. So going back to Avogadro's number, right? We said that 1 mole is equal to 6.02 times 10 to the 23. You can put whatever units you want next to 6.02 times 10 to the 23, right? Same thing like when you have a dozen. If you have 1 dozen, you can have 12 donuts, cups of coffee, dogs, credits in a semester, right? If it does not matter what that unit after 12 is, but 1 dozen always means 12 of something. The same thing for a mole. For every 1 mole, you have 6.02 times 10 to the 23, whatever, atoms, compounds, glasses of water, miles per gallon, dogs, I don't know, right? It can be whatever you want. You can just put a unit right after 6.02 times 10 to the 23. So if I said you have 2 moles of CH2O, how many atoms of CH2O do you have? It's not the word I'm looking for, but I've lost it. Whatever. How many atoms of CH2O do you have? Now what are we going to use in order to get to atoms of CH2O? Molecules. The word is molecules.
Would you multiply by one?
Now you're going to multiply by Avogadro's number, right? So for every 2 moles CH2O, right now you're looking for molecules. For every, if we have 2 moles, that means we have a lot of this thing, right? We have a lot of molecules. So every 1 mole of CH2O, we have 6.02 times 10 to the 23 molecules. Now that means that we have 1.204 times 10 to the 24 molecules of CH2O. Right, is times 10 to the 24 a big number or a small number? That's a pretty big number, right? We need a lot of molecules of this in order to get to 2 moles of it. Right, so that means you have a whole bunch of CH2O molecules floating around. Okay, what questions do we have now? Do you just want to do a little practice with it? now you have 15 grams of sodium chloride. So I want to know how many moles of sodium chloride do you have and how many molecules you have. You want to do this one together? Or try it on your own? You want to try it? We can try it. Yep. Give you a couple minutes. Feel free to work with each other. I don't know what this answer is. I just made it up, so I'll do it myself. Did anyone get the number of moles of sodium chloride we had? Mm-hmm. Did we get number of molecules? They got 1.55 times 10 to the 23. Okay, awesome. So those are the correct answers. Can someone tell me how we're going to get there? All right, started off with molar mass of NaCl. What was that?
58.4.
And what did that help you with?
Molecular weight.
Perfect, right?
Moles.
Perfect. Either one. Great. All right, so you'll have 15.0 grams. We're going to divide by the molar mass. And then we ended up with 0.254 or 257 moles of NaCl. And that's kind of important to look at too. Just as like a mental check as you're going through all of these. When you find your molar mass, that's telling you that you have if you have 1 mole of that, you have 58.44 grams. You only have 14 or 15 grams. Do you have more or less than 1 mole with your starting material? You have less than 1 mole, right? You have about a fourth. Do we get about a fourth of a mole in our answer? Yeah, right? So that's a good check, right? If you multiplied 15 by 58, you're going to get this large number. If you get that many number of moles, that might be a red flag to say, I think I might have done something wrong, right? I have less than 1 mole of starting material. So my number of moles should be less than 1 of my starting material as well. Okay, so 2.57 moles of sodium chloride. And then the same thing, you can do that mental check for your number of molecules. So once we have the number of moles, what are we doing in order to get to molecules of sodium chloride?
Multiply by 6.022 times 10 to the 20.
Perfect, right, so we're gonna take 0.257 moles of NaCl. And then we're gonna say that for every 1 mole, we have 6.022 times 10 to the 23 atoms. Or sorry, molecules. So we get about 1.55 times 10 to the 23 molecules NaCl. And again, is that less than 1 mole of molecules? That is, right? 1 mole is 6.02, but we have less than that for our starting material, so we should end up with less than that for our number of molecules as well. Okay, any questions on working this way? Okay. This one, how much do 17 atoms of potassium weigh in 17 or in grams? So I'm giving you 17 atoms, and I want you to get to grams. Do you want to try this one or work on this one together? Together? Yep. Okay. So where are we starting? We're starting with 17 atoms, right? Is that a lot or little atoms? That's a little, right? We just said that 1 mole has 6.02 times 10 to the 23 atoms of something, right? So we have only 17 of these. And potassium is going to be K. How do we get out of atoms into grams? So what is our molecular mass of potassium? We'll say 10. What are our units of our molar mass of potassium? AMU or grams per mole, right? We can say AMU or grams per mole. Do we have something in grams per mole that matches up with atoms to cancel it out? No, right? We could multiply by the molar mass right now, but then we would be left with atoms times grams divided by moles. Is that give us the mass? No. So what do we need to use in order to get out of atoms? So, right, when we did this question here, we called it a molecule because we had a compound. Right now we just have an element. So that means that we can use atoms because we have atoms here. So we can change our unit when we're talking about Avogadro's number. So instead of saying that we had 1 mole of something, now we don't know how many moles we have. Now we know that for every 1 mole, we have 6.02 times 10 to the 23 atoms of potassium. Or we can change that unit on Avogadro's number. Is this going to give us a really small or a really big number, having Avogadro's number in the denominator? It's going to be really small. Do we expect it to be really small? Yes, we do, right? 1 mole is times 10 to the 23 atoms. We only have 17. That's a really small number in comparison to times 10 to the 23. Okay, so that's going to be our number of moles. If we break this up, then that would be 2.824 times 10 to the negative 23rd moles of potassium. All right, so we get a negative 23. It's a very small number. Okay, what do we do once we have moles? Yeah, now we can multiply by grams per mole because that's going to use our moles. We can cancel out our molar unit and just get to grams. And that's going to be the unit that we're looking for. So I got 1.10 times 10 to the negative 21 grams. Okay, is that a small number or a big number? That's small, to be expected to be small, right? We only have 17 atoms. Those are going to weigh a really, really small amount in comparison to, right, a whole mole of them. Okay, so that's a good like mental check there. Do you want to practice one more like this? So for this one, we have in a sample, there are 1.15 times 10 to the negative or times 10 to the 15 oxygen atoms. And we know that oxygen exists as O2 gas. Right, so we have oxygen bonded to oxygen. How many grams of oxygen is there in this sample? Do you want to try to do this one on your own now? Okay. Let's do that. Give you a couple minutes. Get an answer. Is anyone stuck?
I have 6.11 times 10 to the negative 8.
Awesome, yeah. So we have 6.11 times 10 to the negative 8. And what units are you in?
Right.
Perfect. You want to tell me how you got your answer?
I started off by taking 1.15 times 10 to the 15th, which is the number of oxygen atoms given, and then multiplying that by 1 mole over 6.02 times 10 to the 23rd. And I got 1.91 times 10 to the negative 9, which is moles.
Give me that number again, sorry.
1.91 times 10 to the negative 9.
Perfect.
And then I took that number that I got for the moles,
Mhm.
and then I found the molar mass
Mm-hmm.
of O2, which is 31.98,
Perfect.
because I added 15.99. Or I multiplied it by
Perfect.
to get it.
Right, so oxygen is a diatomic element. You'll learn about that. Did you learn about diatomics yet? I don't think so. So you'll learn about that in a couple lectures. But for the sake, right, it is a diatomic, which means that it exists as oxygen bonded to oxygen. So that means that for every one oxygen molecule, you have 2 oxygen atoms. So its molar mass of O2 is going to have 2 of those oxygen atoms in it. Right, same way how we multiplied the hydrogen by 2 in CH2O. So you need 2 of those. So that's where that molar mass comes from. Did you do anything else after that?
No,
Yes.
and then I got 6.11 times 10 to the negative.
Perfect. Perfect. These probably seem pretty straightforward right now. Once you start learning about compounds and molecules and the moles of something and something else, it can just get a little bit more complicated. But if you can get this down, then everything else you learn after that will be much more simple to grasp as a concept. Okay, but this is perfectly correct. One thing to note is that you don't always have to break this up into 2 steps either. You can just do 1.15 times 10 to the 15 and do 1 mole over 6.02 times 10 to 23. And then you can multiply your molar mass directly from there. If you're able to see that train track of units cancel each other out, if you like to break it up, by all means, if you make a mistake, it's easier to see like what that number was. But you are able to just do that directly as well. If you have a graphing calculator, sometimes that's easier to plug into your calculator. Okay, any other questions on this topic? Does that make us feel more comfortable with it? I will include this on the additional practice problems from this week as well, so you can get some little bit more practice with that in the meantime. Anything else you want to see today? Anything else from last week? I know it's a lot of like concept building right now.
Like when reading the periodic table, like where you find the charges, like all of it.
Yeah,
Just reading the periodic.
absolutely. Let me get a periodic table to plug into this so I can write on it. So. You get the idea of like what's on this. But when we look at the periodic table. Right, it's broken up into periods go across and rows go down. So what are these right here? Do you know what kind of elements those are? This is where helium, neon, argon, krypton, xenon. Those are going to be your noble gases. So do those make a charge ever? Do those react ever? No, not really. You will see a little bit of xenon get in there towards the end of the semester when we start talking about shapes of molecules and shapes of compounds. But for the most part, these are very inert. They don't do it, right? They're in an inert gas. They don't do much. All of your noble gases have a full octet, right? They have a full shell. They all have 8 electrons. Everything on the periodic table is trying to look like a noble gas, right? They want to be as similar to a noble gas as possible. So if we're looking at neon, right, that is our 10th element. Fluorine is 1 element away from the periodic table. Does anyone know how our periodic table is built? What changes as you go from element 1 to 2 to 3 to 4? The mass. But what do you know if you know that you're talking about element 6? It's how many protons, right? So it's built up by the number of protons and consequently the number of electrons. If you're talking about non-ion compounds, right? So, right, hydrogen only has 1 proton, helium has 2, lithium has 3 protons, 3 electrons, stuff like that. So if fluorine is our 9th element, how many protons and how many electrons does it have? It has 9 and 9, right? It has 9 protons and has 9 electrons. Neon has 10. So in order to get to 10 electrons, what do we need to do? Do we need to add an electron or subtract an electron? We need to add an electron. So if we add an electron, then we have protons equal 9. Oops. Protons equal 9, electrons equal 10. What is our charge on fluorine now? -1, right? So fluorine's always going to make a -1 charge. It'll always look like fluorine -1. What do you notice about everything in that row for under fluorine? How many steps away are they from a noble gas? Oh, they're only 1. So all of these right here will always make a -1 charge because they're always 1 away from a noble gas. What about oxygen to the left of fluorine? How many steps away is that from a noble gas? 2. So what charge is that going to make? -2. What about everything else underneath it? Also -2, right? They all have the same properties. They're all going to be a -2 charge. For the most part, nitrogen, phosphorus, and arsenic, right? That group there, this is going to be a -3. Nitrogen and phosphorus for sure will make a -3. We have this little stepwise function there. So I think arsenic also makes a -2, but for the most part, you can say that everything in that third row from the noble gases is going to have a -3 charge. Carbon is where that differentiates, right? This can either be a +4 or a -4, depending on which way you're coming from and the type of chemistry you're doing. Okay, but if you remember -1, -2, -3, those are the big 3 that you need to remember on the non-metal side of it. When we talk about row 1 or group 1, how far away is that element from a noble gas?
Mhm.
Why do you say one? You can go backwards, right? Lithium is element number 3. So it has 3 protons and 3 electrons. If we look at neon, that has 10, right? That's in the same period. So if we try to get to neon by adding it all the way across, that's 10 electrons, or sorry, 7 electrons we need to add in order to get to neon. However, helium only has 2 electrons. So instead of trying to add electrons to lithium, it's going to give it up, right? That extra one it has is going to give it up, and it's going to create lithium with 3 electrons, 3 protons, and 2 electrons. So what charge does lithium make? Lithium always is going to make a +1. What does that do for everything else in the group? Also +1, right? All of these will always make a +1 charge. What about beryllium and magnesium in that second group next to it? Those are always going to make a +2. Okay, what do we call this section here? Close. They are metals. What kind of metals are they? These are what we call our transition metals. Okay. When we talk about a transition metal, it's the group of 10 that's between, right, the second row and then where that second half of the periodic table starts. There's 10 elements in that section right there. Those are all of your transition metals. These transition. They don't always have a certain charge that they're associated with. Some of them do. Like gold and silver always make a +1 charge. But for the most part, like manganese has +2, +3, +4, +5, +7, I think it can make. If I remember correctly. Copper can be +2 or +3. I feel a sneeze coming on, so if I do that, I apologize. Right, but all of these are able to have interchangeable or differing charges associated with them. So they transition between different oxidation states or different charges. So these don't have a set one. When you start naming your compounds, you'll see what you have to do in order to account for the different charges that it has. But for the most part, if you remember +1 and then +2 for your 2 metals on the left, and then your -3, -2, -1, that's going to be good enough to go for what's creating a charge. Does that help your question? Okay. Anything else? Do you feel okay on the topic so far? It'll ramp up. It'll be okay. That won't stay. No, I'm just kidding. Anything else you want to see from me today? Do you want me to just give you some practice problems to try for the last 12 minutes, or you just want to go home? Doesn't matter to me. Couple of practical? Okay.
What's the difference between this session and the SI session?
Yeah, that's a great question. So, right, I'm the IA. I am in grad school. Your SI is an undergrad. So just like 2 different people, right? I didn't go here, she did. So that's just a difference there, and just in terms of the people teaching it. Not to say one's better than the other, we're just different. And then, right, I am here and I prepare for everything, and then I ask what y'all want to see, and I can come up with that and give you stuff there. She will have more problems or more content that's tailored toward what she wants to do that day. How they come up with that, I'm not really sure. But she has more like stringent stuff that she talks about. Here I can talk about anything. I don't really I don't really care what we do.
For the most part, we're around the same content.
They cover around the same content.
What we did last week or the week of.
Yep, absolutely. So it's just a preference on what you want to see, what you like. I hold mine once a week. She has a couple extra sessions that you can go to too. I don't think she does anything extra for exams, but like for exams, I'll have an additional review session before an exam, and then whatever this Wednesday is, it'll be a little bit longer than usual, just so you can go over the mock exam, ask any dire questions about it. So it's just a preference on what you want to see.
Cool, thank
Yep,
you.
absolutely. Okay. Okay, let's try this one. So this kind of goes off of what we just talked about, the periodic table. So I just wanted to fill in the blanks for the following chart. So you're given the symbol, and then the number of protons, the neutrons, electrons, and the charge. And your symbol should have like A, B, and C filled out for all of them. Do you want to do the first one together? Do we remember how to do this together? Okay, so we're given the symbol for MO, which is molybdenum. And you know that your proton is 42. So what does 42 tell us? Yep, it has 42 positive charges, and then we have a charge of +2. So what can we get from that information? We know that it's positive, so do we have more or less electrons? We have less electrons, so how many electrons do we have? We have 40, yep. What goes in the A category? That's the mass. And what makes up a mass? Protons and neutrons, right? Your mass is your protons and neutrons. Okay, so molybdenum's mass is 96. So if we have 42 protons, and we know that overall its mass is 96, how many neutrons do we have? Mhm. What goes in the B portion of molybdenum? The atomic number, which is the number of protons. And then what goes in the C category? The charge, in which that is +2. Perfect. Okay, so what about carbon? We have carbon 13. What does that 13 tell us? That tells us our mass. What do we know that it's carbon, so what can we get from carbon? The protons. Does anyone know what that is? Yep. So we can also put that in the B category. So if we know we have 6 protons, how many neutrons do we have? This one is 7. Yep, carbon 13 is an isotope of carbon 12. Of carbon, not carbon 12. An isotope of carbon. So right, this came from 13 minus 7, or wow, 13 minus 6, which is 7. If we're not given anything of a charge, what can we assume our electron number is? 6. So what's our charge? Neutral. Yep, 0. Okay, then for our last one, we're given protons of 47. What does that tell us? Yep. So protons tell us what our element is. So we know that we need to go to element 47, which is silver. That also goes in the bottom left corner. Silver, we can round to 108, right? We'll say the mass of silver is 108. So what does that tell us? Or does that number go somewhere?
A spot.
Yep, so it's going to go in the A spot. And that means we have 61 neutrons. We said that we're given 46 electrons. So what's our charge? +1, perfect. And that goes where?
In the C spot.
Yep. Perfect. Those have actual letters. It's like A, Z, something else. I forget off the top of my head.
You said that silver and gold typically have +2 charge, right?
+1 charge.
Oh,
Yes. Yep.
would we ever get a case where that's not?
I mean, like probably. They could, just because you're filling out a chart, it doesn't really matter. But for the most part, when they use silver or gold in like a question, it'll be a +1 charge. Yeah. Right, you can make ions all you want, so you can just keep on picking off electrons. So you can make anything you want from these things. And then does that kind of help with using the periodic table and stuff? Yeah. Okay. And then I gave you all positive charges, but you could do the same thing for negative charges. There's just more options with the positive charges. Alrighty. Anything else from me? And then does everyone know where I'm housing all of my information for this? on Canvas? Do you think I should show that? So on Canvas, if you go to, I think I showed this last time. If you go to your class and the home page under resources and contacts. Right, I have all of my information right up top. And then if you click the link to all review sessions, then I will be posting, right, everything here. So everything underneath previous fall, that's from last year. But I taught the same course with Dr. Bengali, so it's on the same, pretty similar schedule. So if you need any additional information, all of that is right there. And then my additional practice problems from last week aren't uploaded yet, but I'll upload those as soon as possible, along with the answers, and then hopefully by Saturday at the latest, this week's are uploaded as well. Alrighty, and that is 7:15, so I'll let you all go. Thank you for coming. If there is anything else y'all would like to see from me to help you succeed, let me know. I'm happy to do that for you.